crystalline solids have long-range order to their atoms or molecules. There's a pattern. And this is why they often have beautiful geometric shapes. This is a snowflake. Water is a crystalline solid. So how do we find out how the atoms and molecules are arranged? Well, X-ray crystallography is a very useful technique. And so some of this should sound a little bit familiar. Electromagnetic waves interact with each other. They cause interference. Remember the guy with the box on the beach? The light waves passing through those two slits caused an interference pattern, and we saw bright and dark spots. Well, X-rays are also electromagnetic radiation. They just have much shorter wavelengths. And so they will also produce constructive and destructive interference. So what they're doing here is they're taking an X-ray source and sending a beam of X-rays onto this crystalline solid. The X-rays have wavelengths that are on the same order as the spacing between the atoms in the crystal. And so these spaces act like slits that the X-rays are going through. And then using an X-ray detector, you can find the diffraction pattern and analyze that. So the X-rays are coming from the same source. They are in phase. So we have these two rays coming in phase, and they're going to hit, this one's hitting the top of that atom and bouncing off, and this one's going through and hitting the top of that atom and bouncing off. So they're traveling a different path length. So ray 2, so that is equal to the sine of theta. Now, I know you all learned sines at some point in your academic careers, and most of you are like, that sounds familiar, right? Sine is a function, and so it's not something you can divide by, because dividing is a function, and functions have opposite functions. So the opposite of multiplication is division, the opposite of adding is subtracting, the opposite of sine is inverse sine. And so all you need to do is be able to find the correct button on your calculator. So on the 36X Pro, there's a button that says sin and sin to the -1. So if I press that button once, it's going to give me sine. If I press it again, it'll give me the inverse sine. So that's what I want. I'm going to take the inverse sine. Let's just start that over again. So theta is going to equal the inverse sine of that number. Or 29.4. That is an angle, and the angle is going to be measured in degrees. We don't do radians in general chemistry. Any questions?